Welcome to the lecture series of hydrogeology. So today we are going to talk about fluctuations in groundwater level. So there are a number of reasons that why there might be fluctuations in groundwater level or in the water table, whether they are falling or whether they are rising. So in this particular lecture we are going to discuss them in three parts. Okay, so first one is that the fluctuations which are occurring due to evapotranspiration. So I'm going to discuss first of all the effect of evaporation. What is evaporation? We all know. What is transpiration? We all know. What is its combined effect? Okay, in relation to, we are going to talk in relation to the depth of the water table, whether they are shallow, whether they are deep, and how the fluctuation, how much fluctuation is taking place. Okay, then I'm going to discuss the fluctuations due to meteorological phenomena. In this, the most important part that you have to understand is the atmospheric pressure. Then I'm going to tell you another parameter, that is rainfall, although this is not a really reliable one, but we'll discuss it, that how if you observe certain fluctuation after rainfall in the soil moisture, maybe it is capturing, it is holding a lot of water, how changes are going to occur in the water level. Then we are going to see some minor fluctuations due to wind and frost. Okay, in which seasons, basically when frosting is there, what is happening to the water level, if spring is there, what is happening. Then lastly we are going to discuss the fluctuation due to tides. So we'll discuss about ocean tides, we'll discuss the amplitude, the time lag between the tides. Okay, we are going to discuss about the wavelength, the total volume. So all these things we'll look into. But if fluctuations are happening very far from the ocean, then they are because of earth tide. So we'll discuss this particular aspect also. This is extremely important because we are going to talk in terms of its coincidence with the changes what happen in the moon, like first moon or the quarter, if I'm talking about the full moon or new moon. So we are going to discuss all of them. Okay, it is all going to make sense at the end. So I'm going to start with the very first one, that is evapotranspiration, and we are going to see how a lot of factors are involved. Okay, so we are going to start with fluctuations due to evapotranspiration, and specifically I'm going to discuss about the evaporation effects. So we are all aware that what evaporation is. Evaporation of water from the ground is actually a process where groundwater moves up to the surface and then it is released to the atmosphere, in simple words. Now there must be certain factors that affect the evaporation rate. Okay, so what are those factors that we'll discuss? First is the water table depth. So if water table is closer to the ground surface, if this is your ground surface, this is your water table. So what do you think evaporation will be? Increased or decreased? It will be increased. Then talking about the soil structure, this is actually very important because it controls the capillary tension. In the initial lectures, we have talked about this and we have discussed. So this is basically the water which is held in smaller spaces. Okay, and it is present above the water table. Now, this capillary tension is actually going to influence the hydraulic conductivity, that how easily the water is going to move up. Okay. Now, after these two factors, the third factor is external conditions. See, if you're having a bare soil and you're trying to calculate the exact evaporation, it will be very, very complicated because evaporation conditions, they keep on changing. Okay, they keep on changing at the soil surface. Then, now the next question is, once you're aware of what evaporation is, which factors are actually playing major role, how water moves upward, how water is moving upward. So you know that under the isothermal conditions, that means I'm talking about the constant temperature, the upward movement of water is mainly in the liquid state. However, you know this thing that if soil surface gets very hot, then what will happen? It will dry out and it will cause the water to move upward in the vapor phase. That means in the gas form. Okay. Now this is in response to the vapor pressure difference. Okay. So now we are aware that how water is moving upward. How what are the factors responsible for the evaporation rate? Okay. What is the definition of it? Now coming to the field measurement of groundwater evaporation. So they are conducted using tanks which are filled with soil. It's known as lysimeters. Okay, so here water table is kept at specific depth. By specific depth means it could be shallow within 1 meter, or it could be below 1 meter, that you can refer to as deep water table. So when water table is within 1 meter of the ground surface, then the evaporation is largely, or you can say mainly, it is controlled by the atmospheric conditions. Those are wind and temperature. But when they are below 1 meter depth, then the soil properties become the limiting factor. And what happens to the evaporation rate? It significantly decreases as the water table starts moving deeper. Now you can see on the right hand side also, this is a diagram where groundwater evaporation is expressed as a 60% of pan evaporation, and this is the function of what? Water table depth. Okay. So you can see this is the depth of water table on the y-axis, and on x-axis this is the percentage of the evaporation. So if you see if your depth to a water table is very less, so that means the evaporation is enhanced, correct? So you can see over here, this is 0 and it is enhanced. But if it reaches this 2, the maximum in this graph, then it is decreased, the evaporation is decreased. So it is a simple concept which we all are aware of. Now moving ahead to transpiration effect. Okay, so whatever, fluctuations in groundwater level, are caused by the water uptake of plants, that is termed under transpiration effect. Okay, because the water uptake of plant is actually a process called transpiration. So what are its effect on the water level? Now see, if you have vegetation over here on the ground and its roots are here, so if these root zone have reached the saturated zone, that means the aquifer, so the amount of water that these roots are going to take up is going to be equal to the transpiration rate, because this is the amount of water which is released to the atmosphere by the leaves, right? And this transpiration, how it is caused? By daily fluctuation, that means diurnal fluctuation in the water table. Now for example, you have thick willows, okay, and you have rapid foliage growth also, so it is going to cause a daily water level drop of averaging around 10 centimeter. So it depends on what kind of plant you have, how much intake of water it is actually how much is the water uptake, sorry, of the plants, and then how much is released to the atmosphere, as I told you, because it is equal to the transpiration rate. Now these daily fluctuations, they essentially stop, but the condition should be that vegetation become dormant, only then it will stop. Because what happens if there are heavy frost, the leaves are going to fall and hence the transpiration will stop. Then if you cut the plants,